Hi there, I'm Scott Lowe with ActualTech Media, and thank you for joining us for this Roadcast video. I'm joined today by Peter Finter, who is the Senior Vice President and Chief Marketing Officer for Couchbase. Peter, thank you for being here.
Thank you very much for having me, Scott. Appreciate it.
So before we get started, I want to kind of level set a little bit. I have a pretty deep history with SQL Server and lots of other relational databases. My very first IT job was building applications on top of relational database systems as a developer. And over the years, I've done lots of things with Postgres and MySQL, all those good things. But they all have one thing in common. They're relational systems. I, at a high level, know what NoSQL means. And I have a high level understanding, very high level, of some of the use cases that it can unlock. I want to help our audience, and I want to help myself understand, what is it?
Perfect.
What is, when you think about relational versus non-relational, tell us why.
Great. Well, it's a very good question. And, you know, the reality is there's been 40 years, maybe even more than 40 years since SQL was introduced by Don Chamberlain and Boyce. And that was the foundation on which we have built everything that exists today, right? And so there's been this tremendous investment in SQL in particular. The power of a structured query language, the ability to organize and structure data has really been the underpinnings of what relational is all about. And we're more familiar with the idea that it's basically constructed of tables with rows and columns, and everything hinges on how you connect between those things. What are the ways in which those are interrelated? One of the problems with that is it's very structured, which means it needs a lot of planning. You've got to kind of identify in advance what are you going to need to be able to handle, and then plan that in. And it's, for many organizations, especially large ones, it takes them days or weeks to agree on what that is going to look like. Basically, that is fantastic if the most important thing in the world is that you never, ever risk any part of that data infrastructure. And of course, that continues to be super important. But about 10 years ago, we saw the emergence of a different approach to managing data, where we moved away from this sort of rows and tables model, and instead we went to documents. And the idea of a document database really speaks to this standard notation language called JSON, JavaScript Object Notation, a simple way to capture and store data in documents where essentially you don't have to define in advance the structure of that data. So the idea of more semi-structured or unstructured data, and input, crucially, the ability to change that more or less on the fly. Like, you can introduce a new data element without having to redesign your entire environment. One of the reasons why that's so powerful is because usually, as developers today, we have a sense of what we want to accomplish, but we then have a new idea tomorrow and next week, and after we put it into production, we need to continue to evolve and move with that. So increased agility was one of the main reasons why non-relational databases came into being. And there were many different approaches that were taken around that initially, which has spawned a family of database types rather than just one database type. But I think at the heart of it, it boils down to this idea of, can you create a more agile data environment where you can more quickly respond to changes and not have to go through that super structured planning process to be able to implement those changes?
So it sounds, I think I had an aha moment, but I might be wrong. So if I'm wrong, I apologize. Planning, absolutely, with a database. Done that for decades, and you have to, if you blow it, it's a mess to clean up.
Right.
But it sounds like what you're talking about is you've got this data set. Now you're going to apply an overlay to help someone make sense of what the data is there in a more programmatic way, and that means that as things come in, you can just change the overlay.
It is a more it actually is changing the fundamentals of where the data resides and how it operates as well, but it provides for developers a more flexible environment. It allows for scale and change, so that you can actually handle now much bigger volumes of data. And part of the sort of thing that's come together around NoSQL is not just the way in which you interact with the data and store it, but also the underlying architecture has changed as well. So the concept of distributed databases has really emerged through NoSQL, where we have this idea that you can actually store data in multiple different locations, different nodes, different clusters, but operate as a single logical entity. And some companies, like Couchbase, have innovated in ways that allow you to scale different data services independently of each other. So now you're not just removing the shackles of sort of the planning process from the data structures, but also the underlying architecture now allowing you to do what's called horizontal scale out. So in the relational world, we're familiar with this idea of scale up. Right?
Yeah.
As you need more data to be stored, you actually increment the capacity.
Scale out is hard.
And it's expensive, right? And we think of it as kind of like rigid and complex and expensive. These are big inhibitors, right? So NoSQL brought into this idea that actually there's a more flexible underlying architecture that allows you to move data around, to be able to replicate data effectively, and to store it in multiple locations without the cost associated with that. And so we're seeing here the use cases that have therefore started to emerge have been largely around where there's unpredictability, right? We just don't know what we don't know. So let's plan, let's do what we can with what we know and then see how we need to change that on the fly to do with volumes of data. So actually now we're talking about unstructured and semi-structured. What do we mean by that? We mean the data that you and I produce. Like when we're using our apps, we're generating so much more data now than we used to. I'll give you a simple example. If you wanted to book a trip, let's say you want to go on a trip somewhere and you need to figure out where you're going to stay and what flight you're going to take. In the old world, our data infrastructure was designed around this idea that you'd have a few options and you'd pick one and then you'd store that as your transaction. That was in your system of record. Well, now we have this concept of interactions. Before there's a single transaction, now there can be hundreds, thousands of interactions. We look at this choice, we pick that option, we test for that, we store that, we come back to it later. All of those things are actually creating more and more volumes of data. And that's just you and me doing our normal life, right? One of our customers is Amadeus, one of the big global distribution systems in travel. And they tell us it can be 3,000 interactions for a single transaction. Now, the relational database world was built around this idea of permanent record of transactions. That was what that really was designed for. How is it supposed to handle 3,000 more times more data, if you will, for each of it, right? And that's why the cost thing became a problem and the structuring became a problem. And so people have been saying, hang on, we've got to be able to move past this. What could we do? And for 40 years, we were brought up on it's about SQL, it's about this, and so the early NoSQL products basically said, look, if you're willing to give up on some of the good stuff from the past, you can do some of this new stuff in this new environment, but you're going to have to learn a new language. You're going to have to learn a new way of doing things. And so companies like MongoDB, basically traded off some of the goodness of the old for the goodness of the new. And that was fine to start with. But then enterprises got serious about it and started to say, well, hang on, shouldn't we be taking the goodness of the old and applying that in this new world? Why can't I just do that? Why can't I take my SQL environment, which I love, so powerful, that query language gives me the ability to get the data I need in the time, the way that I need it. I want to be able to take all the experience my developers have, where I developed over decades, and now apply that in the new world. There wasn't that option until Couchbase came along. And we made the decision early, actually developers do want to use SQL. They want to use APIs, they want to use other ways of interacting with data, but they definitely want to take that experience of the past and now apply it. And so what we've done is to create this NoSQL environment, which is very flexible, and then bring the best and what we call the power and familiarity of SQL into that world. That wasn't really an option, in the early days. And so I think people have had this perception, it's like, well, I got to make this call. Do I stay with what I know and what I trust, or do I go experimental and sort of try this new thing out? And that has been where we've been. Now we're getting to a place where it's actually, you know what? I can actually run some serious apps in this new environment. And that's pretty exciting, I think.
Peter, thank you so much for that level setting.
My pleasure. Thanks for having me.
And thank you for watching.